Hey there, everybody. Welcome back. It's good to see you all again. I hope you've been chugging along and doing all right. Remember, you can always email me. Hit me up on Discord if you've got questions. I'm available on weekends too. I'm here for you. I'm your teacher. Don't forget that. In this section, we are going to do division or dividing polynomials. This is 3.5 dividing polynomials. And the easiest one is doing a monomial, dividing by a monomial. So I think this is just easiest just to go straight into examples. If I have 9x to the fourth plus 6x cubed minus 3x squared over 3x squared. So I'm dividing this polynomial by this polynomial. What we're really doing is we're breaking this up into a bunch of smaller fractions. Okay? And then you can use the rules that apply. 9 divided by 3 is 3. X to the fourth over x squared. We do 4 minus 2. We get x squared. 6 divided by 3 is 2. X cubed over x squared. We have 3 minus 2 on the exponents. X to the first power. That's 4 minus 2. This is 3 minus 2. Here we've got 2 minus 2 is 0. Anything to the 0 power is 1. So I just end up with 3 divided by 3 is 1. And I probably wouldn't put that 1 on this exponent right here. Why don't you guys give it a try? Let's see how you do. 20x to the 9th minus 5x to the 6th. Oops. Oh, fuck it. We'll do 56x to the 6th. Plus 10x to the 4th. Divided by 2x cubed. All right. So I will do this with each term divided by the 2x cubed. The first one, I get 10. 9 minus 3 is 6, so x to the 6th power. 56 divided by 2 is 28. If I do 6 minus 3, I get 3. So x to the 3rd power. 10 divided by 2 is 5. And x to the 4th over x cubed is x. So you're dividing each one in. All right. Next, long division of polynomials. So I'm going to write some quick, simple rules, and then we'll go through it. Always match up leading terms perfectly. You'll see what I mean when we start doing that. You should watch your signs on subtraction. The remainder makes a new fraction over the old denominator. And then D Any gaps in power in the exponents should have a placeholder with a 0 exponent or 0 coefficient. So if you add x to the 4th minus x squared, when you're having the division, you'll have x to the 4th plus 0x cubed minus x squared. That's what I mean by a 0 placeholder. All right, let's take a look at the division. Oh, it works exactly like regular division. Arithmetic long division. So I'm going to run through a quick one of those real quick, just to remind you. If I had 987, we'll say, divided by 6. This is 6 goes into 9871. So each time we see how many times it goes into the first thing, we put that amount above it. We take this number, we multiply it, and we subtract. And we bring down the next number. And we keep repeating that. 6 goes into 38 6 times. 6 times 6 is 36. We subtract, we get 2. We bring down the 7. 6 goes into 27 4 times. 4 times 6 is 24. We subtract, we get 3. Bring down the 1. 6 goes into 31 5 times. 5 times 6 is 30. We subtract, we get 1. 98716 equal, divided by 6, is 1,645 and 1/6. So the remainder goes on top. We have the old denominator. That's how it would be with regular long division. When I was your age, saving a video game meant pushing pause all day. That's right. All right, let's see how it works on polynomials. We're going to start with x squared minus 10x plus 24 divided by x minus 6. So the x minus 6 goes out front. We have x squared minus 10x plus 24 in here. Okay, I want to know how many times what we did up here with the 9 and the 6. How many times 6 goes into 9? How many times does x go into x squared? It goes in x times. I'm going to put an x up here. Up here, if I did 9 over 6, I would get 1 and remainder 3. Here, I don't have a remainder. I'm just doing that. We're going to take this and so you're only matching up the leading terms. That's what I meant by match up the leading terms, and perfectly should happen when we multiply. X times x is x squared. X times negative 6x, or negative 6 is negative 6x. These match up perfectly. All right. Now that we've done that, after that we subtracted 6. Now we're going to subtract that. I think it's easier if you move the minus sign in and change the signs inside so that you don't forget. If you've done it correctly, this first part goes away. 0x squared, and so we don't need it. Negative 10 plus 6x is negative 4x. And we bring down the 24. Just like up here, we brought down the 8. Now we're going to see how many times x goes into negative 4x. Negative 4. Negative 4. And I'm going to multiply it by everything out here. Negative 4 times x is negative 4x. Negative 4 times negative 6 is positive 24. These match up perfectly, which is what they were supposed to do, so that when I subtract, that first term goes away. Conveniently, the second term goes away also. So this ends up being x minus 4. That's called long division. Next example. I turned the page before I was ready to. Got a list of examples I'm working on and wanted to do it. X squared plus 7x plus 13 divided by x plus 2. So we're going to divide x plus 2 into x squared plus 7x plus 13. Try to pause the video and match up what we did last time with what we did here. See if you can figure it out. If you can figure it out right away this way, even if you struggle, you're going to get this so much faster. Okay. I see x goes into x squared x times. I'm going to multiply and I get x squared plus 2x. Then I'm going to subtract that. So a minus and a minus. I get 5x here. I'm bringing down the 13. We do it again. How many times is 5x divided by x? It goes in 5 times, so plus 5. And I multiply. 5 times x is 5x. 5 times 2 is 10. They match up perfectly. I'm going to subtract. And when I move that inside, I end up with a remainder of 3. So that might have been where you got stumped if you work this out. Because we didn't have the remainder left last time. X plus 5. And then we take the remainder and put it over the old denominator. Okay. All right, we're going to kick it up a notch. Six x to the 4th minus x cubed minus 2x squared minus 7x minus 19 all over 2x minus 3. We start off going, how many times does 6x to the 4th divided by 2x? And I get 3x cubed. When I multiply, I get 6x to the 4th minus 9x cubed. And then I'm going to subtract. which when I move the negative in, changes the signs inside. The leading terms cancel like they're supposed to. -1 plus 9 is positive 8x cubed. And I bring down the next term. Here I'm checking 8x cubed divided by 2x. I get 4x squared. So that'll be a plus. 4x squared times 2x is 8x cubed. 4x squared times -3 is -12x squared. When I do a negative here, the 8x cubes cancel and I'm left with 10x squared. And I bring down the -7x. Do it again. 10x squared divided by 2x is 5x. 5x times 2x is 10x squared. 5x times -3 is -15x. When I subtract, the 10x squareds go away. I've got -7x plus 15x is 8x. I bring down the -19. And finally, do one last set. 8x over 2x is 4. 4 times 2x minus 3 is 8x minus 12. And when we subtract here, we're left with -7. So 6x to the 4th minus x cubed minus 2x squared minus 7x minus 19 over 2x minus 3 equals 3x cubed plus 4x squared plus 5x plus 4 minus 7 over 2x minus 3. There is an easier way to do that. That is synthetic division. It's the next video. And I'll show you how to do that when we get there. I just want to show you one that has gaps in it. And then we'll be done with this the entire section. X cubed minus 1 divided by x minus 1. So when I set it up, I don't have an x squared. So I'm going to do a 0x squared and I don't have an x. Those are my gaps. So we go like we did before. X cubed divided by x is x squared. Multiply. We'll do the subtract. And I end up with x squared and 0x. X squared divided by x is just x. X times x is x squared, and x times -1 is -x. When I subtract, I got to subtract everything, so it changes the signs. And I bring down the -1. X goes into x one time. And I've got 1 times that is just x minus 1. When I subtract it, I have 0. X cubed minus 1 over x minus 1 is x squared plus x plus 1. We will actually have a formula on this, formula related to this, in 4.5 when we get to that. That'll be it for this video. We're going to do synthetic division and we'll be done with chapter 3. Peace.